Now that we've talked about what mixtures are and the different types, homogeneous and heterogeneous, we need to talk about the ways you can separate them. One of the key parts about the definition of a mixture is that they are physically combined. That means if they are physically combined, they can be physically separated, right? If I put M&Ms and Skittles together in the same bowl, I physically combine them, and I could physically pick through them and separate them again. But not all mixtures can be separated using our hands. Some, we need tools or different strategies in order to separate them. So one of the first ones we're going to talk about is magnetism. So in this picture here, we have sulfur, which on the periodic table is S, and it's a yellow powder. Okay, it is a non-metal. It's very brittle. It's soft. It's very powdery. We also have iron fillings. Iron, which is Fe on the periodic table, is a metal. So if I have a metal and a non-metal together, and I know that my particular metal is magnetic, I can use a magnet in order to separate them. The magnet will pull the iron fillings away and leave the sulfur behind. So that one's pretty self-explanatory. But what about density? Now you might say, Ms. Nichols, I know how to solve for density, but I don't really know what it means. Well, let's look at two different ways. One is a density column. That's what this picture over to the right is. This is a density column. Now, the reason why it's called a density column is you have a column of several different materials, and you might remember making this in class. But what it means is if something has a high density, do you think it will be at the bottom or the top? Which one do you think is heavier, honey or rubbing alcohol? You're right, it's honey. So if you have a high density, you'll be at the bottom. If you have a low density, you'll be at the top. So when you have something that is separated like this in a density column, so honey and then Karo syrup, dish soap, then water, then vegetable oil, rubbing alcohol, and lamp oil, you can use a pipette or a little syringe to pull out the different components. If I stick a pipette and the tip only goes in the lamp oil, it will only pull the lamp oil out. And you can pull it out layer by layer to separate it. Now, one thing that you should always remember is that the density of water is 1.0 grams per milliliter. Now, that means if water is 1.0 grams per milliliter, everything above it has to be less than 1.0 grams per milliliter. And anything below water has to have a density greater than 1.0 grams per milliliter. So that means if I were to put an object into my density column, and my object has a density of 2.0, it will sink all the way through everything until it lands in a column or a portion of the column that is either equal to 2.0 or greater than. It will find its way into the column. It will find its special layer. So that's why we can do that. Now you might be asking, what is this picture down here? This picture down here is of a centrifuge. You're like, how do I spell that? Centrifuge. Okay, so it's a centrifuge. Most people who use a centrifuge are going to be scientists. Scientists use centrifuge generally to separate small quantities in these little test tubes here, and they spin them round and round and round. So for example, in this picture, they have a sample of blood. And when the blood spins round and round, the different components, which are usually mixed together, will separate. The plasma, which is very light, will be at the top. the blood will be in the middle, and the heavy blood cells will sink to the bottom. So it creates kind of a mini density column within the centrifuge test tube. So we have magnetism and density. Let's look at some other ways to separate mixtures. So the third way is filtration. Now, you should have all done filtration before. If you have ever made spaghetti or macaroni and cheese, you have used a colander or a strainer, put your macaroni in, and let the water drain out. So, in this picture, if I have a solid and a liquid, okay, a solid and a liquid, I use filter paper, which is this white paper here. I pour the liquid into it, and when I pour it in, the liquid will come out here, it'll catch in the beaker, and the solid will stay in the filter paper. Filter paper is paper that has tiny, tiny holes in it, and depending on the size of the holes, depends on which solids it will catch. If the solid is too big to fit through the hole, it'll stay in the paper. But if you have really tiny pieces that are smaller than the hole, it will drain through. You've probably seen this effect if you've ever been washing out fruit or noodles. Some things can get through the holes, but only if the hole is big enough. Let's look at evaporation. Evaporation is a little different because it does not have a solid. Evaporation involves a solution, and a solution has a solid dissolved into a liquid. So a solid dissolved into a liquid. So for example, if I have sugar water, okay, if I put a solution of sugar water in this dish here and I heat it up, or if I have sugar water and it's sitting in a pot on my stove and I add heat to it, eventually the water will start to boil and evaporate. And when all of the water is evaporated, the only thing that's left behind is my solid, in this case, the sugar. But what happens if we have two liquids that are mixed together? That would be distillation. So distillation is when we have two liquids that are mixed together. When we have two liquids that are mixed together and they're both two clear liquids, so not oil and water, because oil and water, one is yellow, one is clear, and you can easily separate them with a pipette. When you have two clear liquids that are mixed together, so for example, here we have water and ethanol. Or you could also have maybe water and hydrogen peroxide. Both are clear liquids. If you were to mix the two in a solution or in a beaker here and you were to heat it up, they have different boiling points. And if they have different boiling points, it means the first thing to start to evaporate is one of the compounds, and what's left over is the other compound. So when the evaporation comes up, it goes through this little condenser, and a condenser turns it back from a vapor back into a liquid, and it drips out. So now we have one liquid here, and the other liquid remains behind. So that will be distillation, is two clear liquids that are mixed together. The last one we want to talk about is chromatography. Now, chromatography is specifically for pigments like ink. Pigments like ink are made up of lots of different colors. And what happens is if you have a piece of paper, like in this picture, and you put a little pigment dot right here, you put your marker, put a little ink spot there, the water or solvent, most of the time water, but sometimes not, will travel up the paper. As it goes up the paper, it pulls the color out and it spreads it. So the yellow will end up here, then the orange, then the red, and it will separate out your colors. So this works for ink, dyes, things along that nature.